Welcome back, guys. This is Mr. Kim, and I'm going over the AP Chemistry 2025 FRQ question number 4. A scientist is investigating the properties of a mixture of CH3OH and H2CO. The scientist generates the following diagram to represent the mixture. A. Identify the hybridization of the valence orbitals of the C atom in the H2CO molecule. All right, so looking at the formaldehyde, it is right here. And looking at the molecule, the hybridization is actually quite easy to figure out, isn't it, right? It's SP, where S is always 1 and P is your variable. And the way we figure this out is you look at the number of neighbors or the connections. So in this case, we have 1, 2, 3, where double and triple bonds are considered as one connection. And then, so it's the number of neighbors or the number of connections plus the number of lone pairs. And then they all should add up to the sum of the exponents of the S and the P, where the X is the variable. So in this case, we have 1, 2, and 3 connections or 3 neighbors for carbon. That is 3, and the central carbon has no lone pairs, so therefore the total is 3. So therefore 3 minus 1 gives you an sp2 hybridization. So then let's write it in. It is an sp2 hybrid. And circle that. And let's go to B. In the diagram provided, draw a single dashed line to represent a strong hydrogen bonding attraction between one methanol molecule and one formaldehyde molecule. Let me go ahead and erase this and let's take a look. So looking at this, we got our methanol right here, and we have a methanol here, and then we have our formaldehyde molecules right here, right? So the hydrogen bond should form between the hydrogen that's attached to F or N, that's right here. This is a candidate, and they are attracted to a lone pair on an F or N. So there's one right here. So therefore, that's the one that we're going to draw. That's probably the easiest one to draw. So I'm going to put dashes. I'm going to go 1, 2, 3, 4, and that should be our hydrogen bond. Okay. Next question. The scientist plans to cool a gaseous mixture of methanol and formaldehyde to form a liquid mixture and finds data on the two compounds. The data are summarized in the table. Okay. Propose a temperature to which the mixture should be cooled such that methanol and formaldehyde will both be a liquid. So let's take a look. We're going to look at then the boiling points of the two substances. The boiling points of the two substances are here. So we want to cool it down where they'll both be liquid. So you want to be higher than the boiling point means that this is where it's going to turn vapor, right? So essentially what you want it to do is you want it to be less than both of these temperatures, right? Because you want it to be less than 338 kelvins, because 338 kelvins is where the methanol is going to boil off, right? So we want to make sure that it stays below 338 kelvins. But at the same time, you also don't want it to, you also want it to go under 254, because at 338, your formaldehyde is going to be boiled off already. So here, let me go back and start writing in here. So you want this to be the maximum temperature over here, because you don't want to go past 254, because at which point the formaldehyde is going to vaporize, right? But at the same time, we got to go to the melting point, and we understand that we want it to be above the melting point of both of these guys, right? Or at least the highest one. So if you take a look at 181, what are we looking at? We're looking at 181. The formaldehyde is melted, and so is the methanol. However, at 176, the temperature would be too low for our formaldehyde. So essentially what we want is we want the temperature to be between these two right here, right? So propose a temperature to which mixture should be cool such that so the answer key is probably going to give you a range, which is going to be probably greater than 181, but less than 254. So I'm just going to write in probably approximately 200 kelvins, right? So 200 kelvins would make sense. Yes. Okay, let's move on to our next question. The scientist analyzes the mixture after it is cooled and determines that 8.59 grams of methanol is present. Calculate the amount of thermal energy in kilojoules that was removed to condense 8.59 grams of methanol at its boiling point. All right, so to solve this one, what do we need? Let's go just like I tell my students, I'm gonna leave some space, right? In fact, what I really should be doing, because this is actually an insert booklet, at least I'm trying to emulate that. This would be 4C, and here you write 4CI actually, 4CII, write it like that. Okay, so in order to solve this, right, what do we need? We need to look at the number of grams of methanol that is present. Okay. Um, so we know that if we look at the heat of let's see, heat of vaporization, right? Um, it says that, where do I get it from? 37, oh, there it is, yes. So enthalpy of vaporization of our methanol is located right here, right? So what is that? That is kilojoules per mole, right? So this is quite easy. All you have to do is figure out how many moles you have, and they gave us all the values, so it's plug and chug. Let's go ahead and plug and chug. It's 8.59 grams, and that is our methanol, right? And we got to convert that to moles, and the given molar mass is like that. That should take us into the number of moles, right? And we know that it is 37.6 kilojoules, and that is per mole per mole. Okay, so that brings us to kilojoules, and it should be what, 3 sig figs, and with this being 3 sig figs, you should get an answer of 10.1 kilojoules. Okay, so I would write 10.1 kilojoules of energy was removed. Okay. All right, let's go on. Next, oh, sorry. Um, oh, that's it. So that was easy. So that's actually question number 4. So I guess that should be 2 points for this question. So I'm guessing that you're gonna get a point for this, right? Calculating the number of moles, and then you're gonna get a point for that. That's 2 points. And then you'll get a point for this. That's 3 points. And then going back. No, actually, I take that back, right? That's 1, 2. That's literally 1, 2, 3, 4, right? Right. Okay, so it's literally 1, 2, 3, 4. So you get 1 point for sp2 hybrid. You'll get 1 point for this. And then in part C, you'll get 1 point for this and 1 point for that. Okay, all right. So I hope this helps someone. Thanks for watching.